Okay, so today we're going to take all the knowledge we've learned in the last couple of lessons and we're going to apply it to try and solve log equations. Okay, so before we get onto the log equations, it's important that we just recap all of our log laws. Okay, and this is where we can rewrite a log back into exponential form, or vice versa, we can write something in exponential form in log form. Okay, these are basically the same thing, just written in two different ways. Okay, and then if we have a log and the base and the value are the same, the value or the exponent must be 1. And likewise, if we have a base where the value is 1, the only exponent we can raise that by to get that is 0. Okay, and then we have the simplification rule and this simplification rule as well. Okay, and then adding on to that, we had our log laws. So the multiplication rule, if we add logs with the same base, we multiply the values. If we subtract logs with the same base, we divide the values. And the power rule, where we can take the exponent in the value and we can bring it down as a coefficient. Alternatively, we can take that coefficient in the front and write it as an exponent of the value. Okay, and then from the power rule, we got this law where if we have a value of 1 over something, we can write that as minus with the base being, or the value being on the numerator. Okay, so as we saw before, and nothing's changed, for logs to exist, x must be greater than 0. In other words, the value has to be a positive number, and also the base has to be a positive number. The laws don't exist for bases or values that are negative, and we also don't use values where the base is 1. Okay, now since both the value and the base need to be positive numbers, okay, when we're solving log equations, just like modular functions, we unfortunately have to check the solutions are valid in the original equation. Alright, so with that out the way, let's get on to solving some log equations. Okay, log equations, generally what we're trying to do is get log of the same base on both sides, because then whatever's inside the log then must therefore be equal to itself. Okay, so over here we have a 2 still in front, all right, and we want to try and get this log base 8 to stand alone with everything else in the log, okay, as the value. So we can use the power rule and we can move that as an exponent, and we can get log base 8 of x plus 2 squared equal to log of base 8 of 2x plus 19. Okay, so now we have the same log base on both sides, and since these are log of base 8s on both sides, if this is an equation and they're true, then everything here must then therefore be equal to itself. And so we can drop the logs and we can just write x plus 2 squared equals 2x plus 19, and now we just have quadratic to solve. So we'll expand, bring the other terms to the other side, simplify, and now we can factorize and find values for x. So we'll get x minus, or x plus 5 and x minus 3 equal to 0. So x can be equal to minus 5, or x can be equal to 3. Now we need to check in the original equation if these two values satisfy the original equation. So what we're going to do is we're going to check. So let's check x equal to minus 5. So here we're going to get 2 log base 8 of minus 5 plus 2 equal to log of base 8, and this will become minus 10 plus 19. Okay, so simplifying, we'll get 2 log base 8 of minus 3 equal to log base 8 of 9, and here we have a problem, right? So the value is a negative number. We can't get a negative value, and so we can say that x cannot equal minus 5. Okay, and the same way we can check x equal to 3, and so we'll put 3 into the original equation, so we'll get 2 log base 8 of 3 plus 2 equal to log 8 or base 8 of 6 plus 19, right? And checking on both sides, we can see that both sides are the same. So if I move this up here, we'd get 5 squared, which is 25. And so we can say x equal to 3 is a solution. Right, so a nice simple example just to show how we have to check all our solutions with log equations to make sure that they satisfy the laws that logs involve. All right, here's a different type of equation. In the previous example, the value or the variable we've been trying to solve, x, has been in the value. And in this question, the value is now the base, right? So we're solving for the base, right? But we're going to follow the same steps. What we want to try and do is simplify this as much as possible to try and isolate x. So here we have 2 logs being subtracted, and what we want to do is we want to try and simplify this into 1 log. Okay, but at the moment we have this 4 in front of the log, so we can't do that, so we're going to move it up as a power. So we're going to write log base x of 2 to the power 4 minus log base x of 4 equal to 2. Now we can use the subtraction rule, so we'll say log base x of 16 over 4 is equal to 2. Therefore, log base x of 4 is equal to 2. Now we're just going to convert this back into exponential form, right? So remembering that this is the base, this is the value, this is the exponent. So we're going to have x to the power of 2 equal to 4. Therefore, x can be equal to plus or minus 2. And just like before, we need to check our solution. So we're going to check. All right, and immediately we can see if we have 4 log of negative 2, we can't have a negative base, and so x cannot equal negative 2. And then we can check if 4 log 2 of 2 minus log base 2 of 4 is equal to 2. Right, we don't break any of the laws, and so x can be equal to 2.